We'd like to thank all of you for attending today's webinar on BIM-Masonry a year later. In March 2013, Georgia Tech was hired to map out a plan to implement BIM-Masonry Phase 1, and they created the map. And then in June of 2013, the real work on the individual groups started. And we'll start with the Masonry unit model definition, the benchmark, and the Masonry wall model definition, and the BIM contractor input. That's what we'll go over today, which is all part of the Phase 2. Next. We started out with, we wanted to recognize all of the organizations that have contributed thus far to the program. You saw just a brief segment showing BIA. We'd like to have your help. BIA is the Brick Industry Association. They have not been involved to date at any significant level with funding. We do need their funding, and we would like you as individuals on the phone to get involved with your local brick manufacturers and get them involved. This wants to be an organization of all the masonry industry, and it doesn't want to exclude one portion of it. I represent brick, and there are others that do, but we do need BIA as a whole. Next. This slide shows the presenters who will be on today, with exception of David Biggs, who is the coordinator for BIM-Masonry. David is out of town, but I and Russell Gentry, John Haymaker, Jamie Davis, Darrell McMillian, and Art Theusch will be the presenters today. And I'm not going to spend a lot of time here because of how much we want to share with you today. As we, before we get too heavily involved, I mentioned briefly that we would be going through kind of an overview of each of our organizational projects, and then we would do a little wrap-up. So I will start, but before we get in next, I wanted to explain what BIM is. There's been two different acronyms, both using BIM as the acronym. One is Building Information Model. This is a 3D representation of an individual component used in a facility along with all of its essential data. Next. This is what that might look like. This happens to be a structural brick. It has some wall systems attached to it, and then you can see on the far right there's some specific data to it. This is the model, but this doesn't represent a building. This is just a small component. And there will be lots of models, thousands of models in a building. This is what the first phase of it is, getting people really to understand what needs to go into the model collectively as an organization. Next. The second definition, building information modeling, is different than the model. This is really considering 5 dimensions. This is the XYZ plane, this is time, and this is money. All of those need to be considered when you're designing a building. It's looking at interoperability, which is the ability for all design software used by architects, engineers, mason contractors, manufacturers, general contractors to communicate back and forth the information. As there are a lot of mason contractors that are on this webinar today. Some of you are using Tradesman or some software to be able to create walls using BIM. Well, there's no connectivity between that and, or very limited between that and the architectural or the structural software. So interoperability is to be able to create the communication between those. Clash detection is where you've got one material running into another in this three-dimensional space, and a lot of times that happens to be figured out on the job as a change order, and there's a lot of money associated with this. Clash detection identifies these interferences early on. You can go into a three-dimensional model and see those, and if there's interference, it brings that to the designer's attention. It is a virtual construction, so it's built graphically before it's done physically. And then parametric means that when they look at each model, it fits in real space. So if you took a picture of me and put me in the model, I wouldn't be 50 times taller than the building. I would fit to scale. A brick fits to scale, a block fits to scale. They're all accurate in their relationship to each other. Next. BIM, the industry confusion here in BIM Masonry is that you only need the database. You don't need the interactivity between these other materials in the software for the structural engineer or the architect's Revit. And there's this assumption that the software is available currently that allows us to design all of these buildings with brick or block or stone, and it does not exist. So we do need a comprehensive database of our industry products, but we need more than that. We need more than just three-dimensional images or multi-layered spreadsheets. Next. What we do need is this complete process and this bigger goal resolved, and that is to really create unity as an organization, as a masonry industry. And really, this has been one of the first things in my 25 years of working with masonry where we've been connected as an entire organization. We need to produce, sell, and install more masonry, and that's what's really driving BIM-M or BIM-Masonry. We need to make masonry more competitive. We need to make it easier to design. We need a software that will connect all of us together. We need to eliminate the waste and manpower, materials, time, and money, which is on everybody's discussion topics about masonry. We're dirty. We take up a lot of space on the job site, and on and on. And so we need to be able to have better coordination among all the parties to make this go together. Next. Ultimately, what we're looking for is this three-dimensional model that has the ability to use our materials the way they were designed efficiently, eliminate waste, eliminate time, make a schedule that works with the contractor, and so that's what this whole BIM-M is looking at, is how do we put all of this together. And it's a big undertaking. In fact, it's a $2.5 million proposal based on a 4-year contract. Next. So what we're looking at, the first project, project 1, is to create a masonry unit model, a definition. We want a database for the masonry units. This project was funded as considered phase 2. I am the project manager for it. Russell Gentry of Georgia Tech is the contractor. We put together some documentation back in December, and that's been released. I have 3 different task groups, one for brick, one for block, and one for stone. We've given them an assignment now to go out and review this document and make sure that it's telling Georgia Tech how we use our materials, how they're designed into a building, what questions and what answers need to be looked at. Next. The second phase, second project, is project 2. This is the benchmark. This is being looked at by John Haymaker and Russell Gentry of Georgia Tech, and David Biggs is the project manager. This is where they're looking at what's actually out there right now, what's being, what are the BIM pieces that are there, and what's being used. The next is project 3. It's the masonry wall model definition. And Jamie Davis is the project manager. She will be talking about this today also. The they're looking at 3 different wall systems, and she'll go into that in some more detail. And then finally, project 4, this is about the mason contractors. What do they need? What software are they currently using? How are they interacting with the architect, the engineer, the manufacturer, the general contractor? And then there will be some training that will need to be ongoing, and that's being looked at by Art Theusch, and we'll hear about that whole contractor side by Darrell McMillian and Art. And that's the end of mine. So Russell, we'll turn it back to you.
Great. Thank you, Jeff. So I'm going to make a short report on the Project 1, the Masonry Unit Model Definition. Just to introduce our team here at Georgia Tech, we're all here in the room today, and we thank you for the support from BIM-M, and are really eager to continue this work as some of the other projects ramp up. My report's going to be rather short because we had a full webinar on the Masonry Unit project in December, and we just released a report to the Jeff's groups who are reviewing this, and we invite others to get involved with the groups. Essentially, the motivation for the Masonry Unit model definition is that we understand that at the heart of any masonry system are all the components that go into the wall, and those components are not described. The masonry units themselves are not described in a common electronic format so that they can be instantiated in BIM or even ordered in a common way across the industry to facilitate commerce, or even trying to understand what the different technical requirements are for masonry units within a BIM environment. So that's the motivation for a masonry unit database. So what are we doing here at Tech? First, we're very interested in stakeholders. So a lot of what we're doing and a lot of what you'll see is that we're trying to understand how the different stakeholders in the AEC, that's architecture, engineering, construction industry, interact with information regarding masonry units from the very beginning of a project where you might be specifying masonry units to even after the building is constructed and you might be maintaining a facade or tuck pointing masonry. So those are important to all of us, and at each of those touch points in the process we're trying to understand what information is required from the stakeholder about the masonry units, whether it be the color, the texture, the strength, the size, the durability, the availability, whether it's a custom unit or a generic unit. All of that information ultimately needs to be put into the data model that is used by the industry to support BIM. And so we're developing workflows to demonstrate how this masonry information flows through a project. And ultimately we're going to be working with the building products industry that publishes this information, such as Smart BIM and Autodesk Seek, so that this information finds itself on the web and into tools that architects and engineers are using now for other building products. When we talk about workflows, what we mean is how do you work in your office, how does information flow in your office, and what software tools are used, and how do you transfer information from one stakeholder to another. And we've identified 13 key workflows. So in the diagram that you see, starting at the far left-hand side in the pre-design phase of a project and going all the way through to the end phase of a project where you're actually maintaining the facade, who are all the stakeholders? And within each of these 13 workflows, we're developing a kind of a formalized diagram using BPMN, which is Business Process Modeling Notation, and basically trying to understand how, for example, here the architect, which is the gray bar in the upper left-hand corner, might be coordinating with a mechanical engineer, which is the second gray bar running horizontally, and how information would flow back and forth between the architect and the mechanical engineer during the energy modeling phase of a building, when, for example, we're trying to assess whether the building is going to meet the energy code or might even be part of a LEED rated project. And so these little gray boxes in the BPMN represent data. They represent an exchange of information. And in this case, what we're showing is the mechanical engineer or the energy modeler making a query from the masonry unit database. And so what information is required at this point? Well, we need the R value of the block. We need the density of the block. We need to know whether the block might be, say, foam filled to increase the R value. And although we're not there yet here at Georgia Tech, on the right, just to the right of the little blob that I've circled, you can see also information being taken from the masonry wall database, which Jamie Davis is working on. So these are all formal ways that we try and understand the processes that architects and engineers and contractors are interacting with masonry and masonry information, so that we can understand how to structure the database. And ultimately, from all of these workflows and data exchanges, we're coming up with a data model. It's not important for me to discuss what this diagram is, but this is an entity relationship model which shows how the database itself is organized. And so this is in process here at Georgia Tech. We're trying to get all the attributes from Jeff Elder's and his group's spreadsheets put into this data model, and through the analysis of workflows, ensuring that we haven't missed anything in the process. We've just released a pretty extensive report. It's now on the BIM for Masonry website on our activity on this project, and we encourage our stakeholders to download the report and read it. And working through Jeff and his 3 task groups, we're going to be having focused webinars on these workflows over the course of the next couple of months. So we encourage you to look out for those. And Jeff, that's all I have.
John, we'd like to have you go next.
You bet. Hello, everybody. This is John Haymaker. I'm an assistant professor at Georgia Tech in both the schools of building construction and architecture. And I also have here Brian Lee, who's a graduate assistant working on this project as well. So the big idea here is, as Russell just described to you, he's been looking at what are the information needs for this future idea of a BIM-enabled masonry process. And we are kind of trying to take a look at that and say, okay, well, so what? What will that enable us? Are we improving processes, and if so, how and how much? And so the big idea is we're sort of interested in understanding where we are right now with our masonry processes, really not using much BIM. Then, you know, there are BIM tools out there. We don't want to paint the doom and gloom picture that there's nothing available that you could do today to improve your processes. There are. And so there's this idea of a ideal BIM-enabled process that you could go out and start doing today. And then there's this future state BIM, the things that Russell and others along with this project are working on to enable this ideal state. And we really do hope and envision that there's you know, quality, cost, time, and safety improvements in all of this all along the way. But you know, as you start to dig into this a little bit, you start to ask yourself some questions like, well, okay, you know, if we enable BIM, it's going to improve our processes, but masonry project with lots and lots of different types of units on it, or is it a structural masonry project with all of those kinds of constraints, or is it your kind of typical CMU and brick project? And so you then start to ask yourself, once you figure that out, okay, well, what design phase are we talking about? Are we talking about using BIM in schematic design or in design development, construction documents, contractor coordination, or the last phase.
Subcontractor installation.
What we're doing right now is we're developing a study to try to look across this dimension and to benchmark kind of where we are, where we could be in the short term, and where we could be in the long term in all of these phases. So looking at each of these different project types across these different phases using these three different types of technologies. And so right now, we're just focused on, and we're just getting started on this process of developing a series of case studies, essentially 45 case studies in all, looking at the use of BIM in these different phases and types of projects. And we're just involved in laying out the first one right now, which is then going to provide the template for creating our other case studies. And I'm going to turn it over to Brian now to talk about his efforts developing this first case study.
Hi everyone. So moving right along, the first idea here is that we want to focus on one case study, which happens to be on Georgia Tech's campus. It's the Engineered Biosystems building. And this is specifically looking at one work task within the subcontractor installation stage. And this is in the basement level of the building, where they're using mostly concrete masonry units. And as you can see here, this outlines all the actors that are involved, or all the members in the workflow that are involved in this basement installation process. And if you start with the green flag for the start node, you see that there are a lot of time they're starting, telling you when certain members of the group are starting their job that day. Also, you can see that there are schedule and construction document inputs for certain work tasks. And if you follow the arrows around, you can see that there's a very big interconnected system here where all the individual players are performing this one unique task. And from that system, you can also find a huge tree of all the different types of actors that are involved. And also, you can start to bring in the elements of the masonry unit database that's being constructed elsewhere and implement them into this model as well. So you could imagine that all of these integrated together could create one unique system that allows you to reference schedules, the building information model, and further breaking down into the specific work tasks and processes. And as I mentioned before, from this you can bring out certain metrics. And here we can start to measure the quality of a certain building, the cost, what you save in cost, the time saved, and general safety improvements. So you can imagine having better scheduling so you can know where certain wall structures need to be constructed without having to go back and do some rework because a certain MEP subcontractor mistakenly places it in the wrong place. So by coordinating all these efforts, you can not waste as much time, save a bunch of money, and make a better quality product in the end. And so right now the CMU and BRIC study is being done on Georgia Tech's campus. And we currently have two other examples that we've looked into. One is a structural masonry building in an apartment complex in Ithaca, New York. And the other is an example of the complex masonry, which uses a lot of different unit types. And that's the health services building at Yale. And this will all be moving forward in a class that we'll be teaching in the fall, where we do further case studies on current BIM states, no BIM states, and future BIM states. So we welcome any input that you can provide on any other buildings or any other groups that you participate with us. So thank you.
Thank you. Jamie, we'll turn the time to you.
All right. There we go. So I'm going to be reporting on Project 3, which involves the masonry wall database or wall definition. And this project is really going to kick off in earnest with Georgia Tech in April with an overall encompassing goal to develop the data model and BIM representation for masonry walls. But kind of as an initial legwork type project, a TMS BIM-M committee was formed for this kickoff project to try to pull some information together from the masonry industry so that Georgia Tech can start in April and be kind of off and running with some of that information. The two work group chairs from Project 1, the architectural and the structural work group chairs, are carrying through, and they are the work group managers for this committee, and that was Maria Viteri and Tomas. We've got about a dozen members in each of those groups, and one of our goals is to try to populate those groups a little bit more so that we can get more feedback across the industry. So we kicked this off in April of 2013, and our goal was to be done and have something to hand off to Georgia Tech at the end of 2013. And we actually did hand something off a little late. We came in January. And so what I'm going to be talking about today is not what our goals are, but actually what we've completed to date and a little bit about what that deliverable was. We had two face-to-face meetings. I'll just mention TMS meetings in Vancouver and Herndon, which were very good, very valuable. We had a lot of input, so that definitely helped us along. Next. Next, Russ. Russ? Okay. Back one. There you go. So our initial task that we were tasked with for this kickoff project was to provide 10 typical masonry wall definitions to be used by Georgia Tech for their work in the future. Next. Of course, you get a bunch of overachievers in the room, and that goal expands. So we actually built upon that goal and said instead of giving some static representations of 10 different masonry wall sections, maybe we should step back and take a more global view. And so what we ended up developing was a matrix that would define all those different variables that are considered when you're developing any type of masonry wall system. And then we developed some input on which of those variables would be included in the model at various levels of development, or LOD, and I'm going to get into that a little bit more later. And then we provided the graphics as a backup that would depict some of these typical masonry wall sections at an LOD 300, 350, and 400. And as I said, we handed this off in January. So next. So this is the matrix, and you don't need to read it, obviously, but I'll just point out a couple things. So this was kind of our big picture matrix of all these different variables that you would need to think about in putting together any type of masonry wall system. And I'll just, actually, I'll just point out on this slide the color coding. So you can see there's some yellow, green, and blue that's color-coded in this matrix, and that will be significant as we move on here. Next. So in a big picture, if you look at a wall system, you've got single wife, you've got cavity walls, anchored veneers, adhered veneers. We took a cavity wall non-composite and we developed a matrix for a typical non-composite cavity wall. And as you can see, there's other arms of this matrix which could be further developed down the road. And for a cavity wall layer, we defined a basic veneer layer 1, a cavity layer 2, and a backup layer 3. And then next, Russ. And then we would take each of those arms and expand upon that even further to define what some of the variables are. So what you're seeing here on the screen is one of the arms coming off the veneer layer 1. And here we're defining, major categories like the material, the coursing, the bond pattern, the movement joints, the flashing, all things that would have to be considered. And for each of those major components, all sorts of other decisions and data that would come off of those major categories. Again, I'll just point out the color coding, the yellow, the green, and the blue, because this kind of segues into our LOD chart that we developed. Next. So I want to talk a little bit about LOD, because this really became a question in our group meetings and in the meetings that we had face-to-face. There were a lot of questions about LOD and how this impacts the model and the wall development. And I think the easiest way to think about LOD is the level kind of time, effort, and money that you want to devote in educating your model. It does not really affect what you're going to put out in a construction set of documents. Obviously, you have to put out all the information that you want in a set of construction documents. But the amount of information that you populate into a model is a question of the LOD and really the end use and downstream use of what you're going to do with that model. So it's kind of akin to educating your children. If your child's dream job in life would be to work at a check-in desk at a hospital, then maybe you would get them an associate's degree. If their dream job would be to work at a business office in that hospital, then you would bring them up to a bachelor's degree. And if they wanted to be a brain surgeon, you'd bring them up to a PhD. And it's kind of the same with your LOD in a model system. If you're going to, depending on what the downstream use of that model is, you're going to continue to educate it or increase the data in that model more and more and more. So one of the things that we did look at is a document which is out on the street right now, came out in August of 2013, which is the level of development specification that was put out by the BIM Forum. And this document kind of develops and gives guidelines for how you would increase the education of your model depending on which LOD you're at. And you can see on this chart at the bottom that going from a steel construction point of view, going from LOD 300 to 350 to 400, you are putting more and more information into the model and educating it. So from an excerpt of that BIM forum, their LOD 300 for a masonry wall system would be a composite model assembly with an overall thickness that accounts for all the different layers, veneer, structure, insulation, and that you wouldn't start breaking the model up into separate layers like veneer or backup until you got into a higher LOD 350. So with the input that we were getting from the industry and using BIM, you know, we have some discrepancies, I guess disagreements with the level of development of a wall system for masonry. So we differ a little bit from what the BIM forum has put out there. Next. Next. And this is the LOD chart. So this is where the color coding comes in. We've got the yellow is LOD 300, green is 350, and blue is 400. And again, this is all tied back into the matrix and which variables should be input into a model at these various levels. And just for instance, I mean, this is really where the conversations got lively, and there was a lot of input that was very valuable, because obviously there are very different ideas about what should be kind of standardized in an LOD 300 or 350 or 400, and what you know, what everybody thinks or could agree upon for those levels. But just as a for instance, you know, in an LOD 300, it was kind of general consensus in our group that the Ys should be modeled independently, that there should be separate layering systems. And so that's what our group is recommending to Georgia Tech. It was also pretty widely recommended by everyone in the group that the veneer and the backup system should have some kind of a smart wallpaper on it that could show coursing and bond patterns. So all of this, you know, differing from the recommendations of the BIM forum, but it's being expanded upon from, you know, recommendations from within the masonry industry. And then moving to like an LOD 350, where now you want to make your model a little bit smarter. You want to put a little more data into it. showing bond beams, showing locations and heights, having those bond beams flag a little differently for clash detection, showing vertical bar and grout locations, those types of things. And then the LOD 400 is the real downstream use. That's where, you know, the contractors would be using it. That would be like virtual design and construction, where everything is populated in the model, the flashings, the weeps, the mortar net, the vapor barriers. So everything that you would need to build the wall system would be in the model. Next. And then coming out of that, we have some graphics that would represent combining the matrix and all those variables and the LOD chart and which variables should be included at different LODs. Then we had a series of graphics that would depict what each one of those wall systems would look like. So this would be an LOD 300. You've got your basic Ys depicted. You have a smart wallpaper that's showing coursing and bonding. Next. And here in LOD 350, we're making the model a little smarter. We're going to have some more downstream use of the model into analytical programs. And now we're showing bond beams and grouted cells, and those are a little bit smarter for clash detection. Next. And here's the LOD 400. So this is your PhD degree, which would show all the elements that you would need to build this wall system. Next. Another slide in there.
Okay, so
there we go. So our future goals in moving forward are to continue to work with Georgia Tech on their development of Project 3. We're hoping that we can advance those data fields in the matrix and get some more input on that LOD chart, because that's really where the fun lies. And that's all I have.
thank you, Jamie. Darrell, we'll turn the time over to you.
Okay, thank you very much. Hello, everyone. And I'm going to be talking about Phase 2, Project 4, which is contractor input is the general heading for that. Once we got started, as far as implementing this project, we realized that we probably should do a little split here. And so the Phase 1 roadmap identified 8 tasks. And so we divided tasks 1 through 7 into one project, which we're calling Contractor Input Project. And of course, task 8 is Contractor Education, which Art is going to speak to once I am done. Next slide, please. The task 1 through 7 is going to focus on Mason contractor input, along with some GC and some other contractor type input. But this is very important because, at least to me, for BIM for Masonry to really hit its fullest potential, it needs to find its way all the way down to the job site. And of course, that's going to involve our Mason contractors and our Masons that are actually doing the work. You can see here the 7 tasks as far as headings. And next slide, please. To kind of help us out here, I have further reduced that down to 3 main goals. There we go. That is to identify best practices of BIM use in other non-masonry subcontractor areas. We're seeing BIM being used by a lot of other subcontractor types. So we'd like to capture some of that data as we can. We'd like to solicit input from general contractors and construction managers, get their views on what BIM-enabled masonry might look like and what some of their needs might be from future masonry BIM development. And then the main focus, I feel, is to prepare some detailed masonry scenarios of use. In other words, we need to look at current mason contractor processes and try to find areas where that might benefit from development of some future BIM tools. And you can see some of the areas there, and we'll expand on that a little bit here in a minute. Next slide, please. To that end, we are forming, have been forming, and currently still are forming the Contractor Input Work Group, CIWG, and recently David Biggs and I manned a table at the World of Masonry in Las Vegas. We shared some space with MCAA, thank you very much, and we had some materials there for designers and contractors, and we had a lot of good response. And we also now have a website, and this is not to compete with the BIM for Masonry website. This is mainly for as a tool for communicating between work group members. Next slide, please. You can see this is the welcome page there, and it's just going to be a tool, as I mentioned, so that the work group can carry on its function. That we'll have some documents there for the work group. We'll be doing some surveys and so forth. Next slide, please. So what we have to date is these are the responders, the Mason contractors who have responded either to general email requests or from World of Masonry or from meetings that I have attended and others have attended. We've got a pretty good spread so far. This is about 20, 23, 24 contractors. There's plenty of room for more. In this case, more input is better. Next slide, please. Next slide. Thank you. No. I must be having a little bit of a lag. I'm not seeing all of it. There we go. Once formed, we will, as a group, begin to gather input from the contractors. And we'll do that through surveys, email discussions, conference calls, and so forth. We'll be, the goal is to share that information with the initiative for use in later phases. And matter of fact, the need for contractor input will continue through phase 3. Next slide, please. Next slide. Is it available? Thank you.
Darrell, this is Russell. We're seeing the flow chart. You have it now?
Is the global workflow?
That is correct. That's what's on our screen.
Got it. Thank you. Yeah, that's what I need. While we've been forming the work group, we've been doing some work and trying to identify the work path here for the group. And you can see we have 3 columns here, which represents the 3 areas we're going to focus on. GC, CM input on the left, and on the right is some non-masonry practices we're going to look into. But the center column is the one that's going to be most critical, I think, for our Mason contractors, and that is identifying the scenarios of use, trying to fine-tune those. We're not really trying to forecast what kind of tool may result from this, but rather what are the processes that need to be addressed by future tools that would make these processes work better for our Mason contractors. And the goal is to boil this all down into a final report sometime in January 2015 to hand off back to the initiative so that that input can be factored in as the initiative moves on. Next slide, please.
You may have to discuss without actually seeing here for a minute.
Okay. The next slide I was looking for was the there was a little bit of a Gantt chart, just to let you know that we do have a little method to the madness that we're going through. We do have a schedule that we're trying to adhere to, and also, the slide after that is scenarios of use planning. I don't know if that slide is available.
This is Russell. Jeff, can you see the scenario view slide?
I see the scenario of use slide, but not the scenario of use planning slide, which I think is where Darrell is right now.
Yeah, it should be, I'm guessing, slide 52.
I think we're all kind of frozen here.
Yeah, I'm on slide 50.
Which is where I think everybody else is too.
Well, let me just talk a little bit about the scenario.
Well, keep.
Hello, should I continue?
Yes, go ahead, Darrell.
Okay, thanks. The scenario-based planning basically has been divided into 4 categories. The design phase, pre-construction phase, construction phase, and post-construction. And we're going to try to identify in each one of those phases scenarios of use that would pop up and might be useful in developing the future tools. And it was just an appeal to any mason contractor out there that is interested and would like to offer up input. We'd be glad to have that. You can go to the BIM-Masonry.org website, or if you caught the website for the work group earlier, you can go to the website and you can let us know you'd like to join in there. Or at the end of the presentation, I think there is email addresses for the speakers. So just send Darrell McMillian an email, let me know you'd like to join in. We'd be glad to include you in our process. So with that, I'm done.
Art, we'll go ahead and have you, even though you're not going to be able to show your slides here, at least initially, go ahead and get us started if you would.
Okay. This is Art Theusch. My role in this whole effort was brought on to work with the construction managers, and we also started focusing on, I was also brought as a component to look at training. And when we first sat down and looked at training, how do we train masonry contractors to use building information modeling? And we started thinking, okay, there's all these great things that we can do with it. And with the end in mind of a software that gets developed through this effort, taking masonry contractors and teaching them how to use that will be great. But we realized there was a big gulf that we had to cross between where they are currently now and where we want them to go. And so we had to step back a ways and say, okay, what are the steps we need to take to get them from square one, somebody that has very limited interaction with technology or computers, and then how do we get them all the way to using some fairly advanced software that allows them to do masonry models for all the different components we talked about today. So one of the, look at my slide here. So we said, okay, how's this, look at the way that technology is interacting with them. You know, the younger generation has moved very rapidly using things like Facebook, Twitter, email, and everything, where a lot of our masonry contractors that have 20, 30 years in the business, they're used to being up on scaffoldings, putting brick in place. So how do we slowly integrate them with some of this newest technology? And so we stepped and we started, we developed 5 courses. One was an introduction to computers, which David Biggs has worked on. The second phase was introducing them to mobile devices and some of the concepts that are being used with mobile devices, which is we're currently working on that draft right now. The next phase was estimating and scheduling, so that somebody that might have these 30 years experience can integrate some of the new technology in the industry, as well as practical principles that are used every day for pursuing work. And I'll walk them through basically taking somebody that might be kind of at the end of their use in the field, but still has plenty of life in the masonry industry within the companies, and giving them those new skills. And then the 4th step was, is there a BIM course out there that we could use for introduce them to BIM concepts? And then the 5th step would be actual training of the software once we get to that process where we adapt the software. All right. Are the slides getting up to date here? I'll keep going even if they're not.
What slide?
No, they're
I'm on about 57.
we're on, and you're on 53.
Okay. Yeah, so I covered that stuff there, yep. Okay, so we started looking at, okay, what are the things that, text messaging is something that's really come around in the last 5 years or so. But a lot of our contractors, for example, my father, who's got 30 plus years in the industry, he doesn't text message, he doesn't even know how. And then you click next. Where younger generations are abbreviating everything. They're using, BTW, BRB, things like that. And then click on. And then you've got Twitter and continue on there. Next slide. When you got all this crazy gibberish, that means, what does that mean to people? So these are some of the things that we've kind of walked through. You can go to the next slide. So how far do we take this? Obviously, we don't want to do examples on the last page per se, but we're looking at the devices that have really changed our industry in the last few years. 5, 6 years ago, getting a laptop on a construction site was nice, but it wasn't an everyday thing. In the last 2 or 3 years, iPads and mobile devices like that radically changed our industry and the development of apps and smartphones. And so this course that we're working on right now is focused on this. How can we teach contractors how to use these mobile devices? And how can it change their productivity on job sites? For example, I was on a job site this summer where when the job started, I went from carrying my laptop around the site to, by the time all the right apps were available, 4 months later, I was carrying around my iPad and a tape measure because I had everything on my iPad. So we want to teach contractors teach the masonry contractors how these tools can help them make them more productive and give them the information they need right at their fingertips, which this BIM for masonry is all about, the information in these software. So next, please. So one of the components of this, we'll be looking at not just mobile devices, but what are the applications that are out there. For example, a couple of examples here, you've got plan grid, you've got fax machines. All this stuff can be done, compasses can all be done from a smartphone or an iPad, and we want to make contractors aware of that and start to equip them with new tools that they didn't see as tools before. Next. And then introducing them to the concepts, for mobile meetings. I mean, we're on a GoToMeeting right now, but a lot of these people aren't even aware of what these are and how these tools can be helpful to them. So this will be another component of this mobile device training course. Next, please. And then one of the last components of this is just start to introduce them to the concepts of the cloud and how all these things can be connected to a cloud. So no matter if I'm using my laptop, my iPad, my smartphone, or my desktop computer, I can have all the same information all up to date on any of these devices at any given time, and just explaining the power behind the cloud and how that can help them. Next. And then this is the third stage of the training program. This one will probably be we'll start rolling on this one late summer, and introducing, getting the concepts and techniques of how to estimate, and then introducing different software out there, different concepts of reporting, things like that. And then next. And then the second, this will be an 8-hour training course here. So the first half will be estimating concepts, and the second half will be scheduling concepts. And just walking them through similar things. What are some of the concepts that are used? What are the software that's out there? And level of detail and things like that. And then next. And then the fourth course is one that's already been created by the Associated General Contractors of America. And we've gotten permission from them to teach their course, their Unit 1, which is Introduction to Building Information Modeling. And so we'll start rolling those ones out here pretty soon too. These are also available around the country through the Associated General Contractors, but we've partnered with them and been given permission to teach these at specific masonry events that we choose. So that brings me to the conclusion of where we are with the training for masonry.
Art, thank you. Next, Russell. So you've heard what we've been doing. Now we'd like to get you involved. We would like to have your support and your assistance in moving forward. If you're already involved, we thank you and we encourage you to continue. If you haven't gotten involved, we're going to ask you that we'll put each of our contacts information on the screen next, but we'll ask that you contact us and join us. We'd like you to join one of our task groups. We want you to get involved. We need your help. Obviously, as you look around and see your area is different than every other area. The people in the Northwest are doing things different from the South and from the Northeast, the Midwest. There's all types of issues that are different. And so without your assistance and your support and your involvement, we won't be able to address all of the issues that you face individually in your market. So get involved, help us out. And then stay in tune for upcoming projects, upcoming webinars that we've got going on. Finally, we'd like to ask you to continue your donations, either through MCAA, through your other associations. We do need your support. We're looking for a lot of money, $2.5 million. It seems like a lot if you had to pull it out of your pocket. But if we were to take every mason contractor, every other installer, other products, the manufacturers, and all of us collectively put in a little, we wouldn't be looking at a lot of money from any individual group. So we hope you'll support us. Russell, if you'll go to the next slide. On behalf of all of the presenters, we would like to thank you for taking your time to join us today. Here are our contact information. We'll leave this on the screen. And if you are interested in one of the topics or all of them, you can contact me or contact the individual that was presenting today. They would love to have you join their project. And with that, if you have questions, we'll open this up to individuals with questions and we'll try and answer those. But we thank you for your time and hope you'll get involved.
Well, thank you for a great presentation. We do have a multi-layered question from James Wells. So I'm going to unmute your line, James. And well, in 1 second here. Okay, James, can you hear us? Okay, you had quite a few questions, so I thought it might be easier for you to just talk directly to the presenters.
Oh, can you hear me?
Yes, we can.
Yes, I guess my general gist of my question is, how much is this going to cost the architects? Is it going to be more than the $6,500 that Revit now costs each architect per head that works on it? And how is it going to be translated or delivered to commercial use? What sort of format? Are you going to create a whole new program that they would have to buy, or will it be just an add-on to what they already use in Revit or ArchiCAD or something like that? And
Russell, do you want to try and respond to this?
Yes. Yes. So this is Russell Gentry at Georgia Tech. I'll answer the first part of the question. We're writing a software specification that we're delivering to the existing vendors of BIM software. So we would hope that companies like ArchiCAD or Autodesk Revit or Bentley Architecture would begin to integrate the ideas that you heard presented today, especially those presented by Jamie Davis, without any cost to architects. So we imagine that these data models for masonry are going to start showing up in the commercial software that you're using today. We don't anticipate writing new software, especially here at Georgia Tech. Instead, what we're trying to do is act as a unifying organization to present our ideas to the existing software vendors.
Oh, I see. So they would essentially you're donating this to them.
That's right.
Oh, that's amazing. Well, you should ask them to reduce their prices then.
We'll ask.
Because if they're getting millions of dollars worth of input, it would certainly behoove them to pass that on to all the architects that are on a razor thin budget.
Well, I would make a comment here at the Digital Building Lab at Georgia Tech. We do get the support of the software vendors. So in some indirect way, I would say that they are already very interested and are in fact supporting this work.
Oh, I see. Thank you very much for your response.
Okay, we do have one other comment. It says BIM needs to show grout lifts and grout pours. Is that something that will be addressed?
Actually, that's
Jamie, do
something
you
that
want to
we
answer?
were suggesting when you got into a higher LOD, and it is on our LOD chart, is that you do start to look for grout sequencing, which would be significant in trying to estimate the job for time and money, would be in like an LOD 400.
Okay, another question we have is, can the BIM software make the wall more efficient, use lighter materials, etc.?
Yes, we're hoping, this is Jeff, one of the things that we looked at initially is the ability to change wall systems with at least initially in the schematic design in that lower LOD. You can go in, make changes with it. When you make a change, there will be a cost associated with that wall system change. And so you'll be able to make comparisons between smaller units and larger units, brick veneer and block backup versus structural brick versus brick veneer over wood studs or steel studs. You'll be able to look at the costing difference between labor for one material and another. And so we're hoping that this will give us significant labor savings. One thing also that we're hoping is that, for instance, Tradesman is a masonry software package that right now isn't communicating with the architectural drawings. We're hoping that when we get the architectural and structural set completed, that they would be able to do shop drawings. And instead of a mason contractor having to hire and render all of the walls of a building and sequence those could all be sent to tradesmen in the form that they would be coming out of Revit or the structural package, show the placement of the reinforcing, the bond beams, the wall ties, the anchors, anything that's associated with it. Mason contractor can identify portions of the wall immediately, send them out in the out onto the job site with a tablet, have them identify where the work is going on, put in the actual production of the day, have it kick back into the Mason software. Over a period of time, we'll start to get better productivity rates rather than maybe what's in Smart Read Connect or the RS Means cost data, and be able to get better information. So yeah, we're hoping that as we put this BIM together, that it will allow us to save significant dollars, both in looking at the types of materials. I mean, that was one of the things that was driving this. How do we compete with precast panel? Precasters have already got this software. They did this several years ago. They're in a second or third phase of updating their software. So for us to compete, we need to make it easy for us to design and also take it right from design all the way into maintenance. And so that's what we're looking at.
Okay, and as a follow-up, they want to know if it will, if it'll let you know if the system meets strength requirements.
Well, that will be part of the structural software. So as you put in a product, with that product will come all of the data that is associated with it. So the F prime M associated with a block or a brick, it will have all of the strength characteristics of the material. It will be able to determine the flexural strength, the cracking moments, and so forth of the materials. And so, yes, we're looking at being able to put in, just as if this was a structural steel member that currently has BIM, all of the sizes are in there, all of the properties associated with that material, the design strengths, and that information goes immediately into a Bentley structural package, and it's used for design. And we look at this doing the exact same thing, giving us the ability to actually design buildings using materials that are input.
Okay, another question is, can we lighten the CMU so it performs the same way but allows the mason to be more productive?
Anyone want to take that one? I'd be happy to respond, but Darrell or I think my perspective is, as we're looking at materials, you'll be able to look at the impact more quickly at what a higher strength material does. So rather than taking weeks to design, if you've got the capability to put material properties in and say increase the strength while maintaining section properties, you'll at least be able to look at the impact of that more readily on a building as a whole rather than as a component. I'm not sure if that answers your question, but
Jeff, I would add on to that just briefly. I think it's going to be important at the preliminary design stage when you look at things about, like, should I use this lightweight material, that lightweight block, or that lightweight block. The designer is going to have some feedback at that moment to understand what it means to go from a medium weight to a lightweight, what it means for the production. So we're going to have that information available either somewhere within perhaps one of Jamie's LODs or something, or we're going to have the ability for the mason contractor to interact at that point and say, yeah, you want to try lightweight? Let me give you a number. Let me show you what that does to production. Let me show you what that does to the overall cost. So I think we have lightweight products available. We're just going to have to make sure that they're going to be part of the decision process as we go down the road.
good feedback, good point.
Okay, we do have a follow-up question. Says, I'm thinking of eliminating the heavyweight blocks altogether.
Well, there may be reasons why you would want a heavyweight material, either for strength or, for overturning. So, I mean, without really knowing the design and what the intent is, you may or may not want to. Obviously, if I'm looking at seismic issues, maybe taking some weight out of a building is important. If I'm supporting, something at a lower level, and I can achieve higher design strengths with a heavier weight material, then I might use that just to control the overall width of the material. So that's what this all does. This BIM allows you to take a look at a deeper level the products you're using, and if it's appropriate, use a different one. I'm not sure that you want to throw the baby out with the bathwater if it has a function and a purpose, and it also has a cost associated with it. Some manufacturers don't have access to lightweight aggregates, others do, and so regionally it may be an issue where you can't even, it might have to be freighted to bring in a lightweight material. So this is going to have some regional impact as well. Others want to comment on that?
Okay, we have time for just 3 more questions. The one Peter was trying to ask was how will this affect the time to complete an estimate?
As a mason contractor, Darrell, do you want to go ahead?
Yeah, I think the potential is to reduce that estimating time, especially if the models communicate and we have that interoperability that we need. You know, right now what we see is the architect or the designer doing a model, parts of it or none of it maybe gets handed off. The GC's recreating a model. We have the mason contractor creating their model and their estimating software. So as more and more we can get where we can share that one model, share that one set of data, that should speed up the process quite a bit. Also would help to reduce the possibility of overlap and errors. And in my mind is that step we need to get the collaboration from the mason contractor in the early design stage, so these design decisions can be made with good data and good information.
And this is John Haymaker too. I just wanted to point out that the BIM benchmark project also is intended to kind of provide some hard data to that question. It's a great question, and so we're trying to answer that question with some specificity in the context of specific case studies, trying to really be explicit about how the information might actually improve the process and the end product.
Well, and let me add one other comment to that, and that is one thing that we hope this will do as you look at the LOD 400, as you start identifying materials, part of the estimating is going to be done for you, because you'll know, hopefully at some point we'll be able to tell you exactly how many pieces of bond beam, their 8-inch bond beam, and what quantity of shapes there are. And so these unknowns that we see all the time from mason contractors, we're waiting for weeks for somebody to tie up the order and give us a final count on material. As a manufacturer, you'll know what the colors are, you'll know what the sizes are in the project, and so the estimating will be a lot more straightforward than it is now. Did I miss something? Where were these special shapes? How many are there? Were there color changes, texture changes? If all of that's picked up in the BIM software, it will tell you what's there rather than you having to guess where those individual pieces and parts are.
Okay, another question is, how will you handle regional differences such as unit sizes, fire ratings, or flashing at the base of single width walls, which is done in non-seismic areas only?
Jamie, can you respond to that?
Yeah, the kind of end goal here is to provide you with a program that addresses all the different variables, like we were showing in that matrix, that can and will be used when you're putting together your masonry wall system. So you as the designer are going to have the power and the ability to pick those variables that apply to you in whatever region you're at to create your wall system that's applicable and makes sense where you are designing. It's not it's not like these wall systems are just in the program and they're already developed, and therefore it wouldn't apply to different regions across the country. The variables are what are going to be available, and then you create what you need.
Okay, thank you. And our final question is, are you considering all the R values for materials from state to state? And is the database going to be also based on state to state?
This is Russell. I'll take that question. I think that's a really good question, and I think that right now we are not representing individual materials in the database, but we're providing the manufacturers the ability to give their thermal property data of their block in the database. So, for example, if you're a West Coast block manufacturer or a Northwestern block manufacturer, you put the properties of your block, your the block that you sell in the database, and that means that the architect and energy analyst can use specific properties of your block as opposed to, say, generic properties from the NCMA. It's not necessarily the idea that the database contains all of the mix design information or specific properties of the individual mixes around the country. But if you're making a block now, you can certainly put in the specific properties of your block if, for example, you have a better R value than the kind of normal generic properties.
Let me respond also to that. I would see, Russell, that we would have a placeholder inside this worksheet, this database, that would allow a manufacturer to identify the regions that they would supply materials. So you may have one supplier that says, I'm going to supply material from coast to coast. You may have another one that cuts their area, their region down to maybe 200 miles. And so you would have the ability to be able to identify how far you would normally ship that material. Thank you very much.